Two-way tables and probability. You guys have seen a two-way table way back, some of you in first trimester, others of you a little bit more recent. Two-way tables kind of help make it easier just when we're finding probabilities. We'll draw a lot of these, and right now I'm giving it to you, and eventually I'm going to give you the information. I'm going to say, hey, take this information, create a two-way table from it, and then let's calculate some different probabilities. And this first example here says, consider the example on page 303. Suppose we choose a student at random, find the probability that the student, and then we have parts A, B, and C. So rather than reading the example, I think this one's kind of self-explanatory. We have people with pierced ears, and then we have gender, you have male and female. The first one says, find the probability somebody has pierced ears. So instead of going in here every single time and I'm like, well, what's the probability somebody has pierced ears, and writing this whole thing out, writing probability of pierced ears every single time, what we do is we go off to the side and we're like, well, hey, let's say A represents something and B represents something else. So if I'm saying let's find probability of pierced ears, I might just say let's let A represent pierced ears. And then over here I also have B, which is representing our genders, and specifically, I'm just looking in my question. I'm going to go a little more specific than gender, and I'm going to say, like this one says, a male with pierced ears. So I'm talking about, in that case, finding probability of a male with pierced ears. So instead of saying, like I said, instead of saying probability of pierced ears and writing that all out, I'm going to say, well, probability of A, I'm taking pierced ears out and I'm putting A in instead, because over here I defined A to be the event pierced ears. So then we look at our table over here, and who are my people that have pierced ears? All these people said yes. I have 103 out of 178 students have pierced ears. The next question says, is a male with pierced ears? So I'm saying we could go in here and we could say, what's the probability of being a male and having pierced ears? But that takes up a lot of room and it's a lot of time to write it. So shorten it up. I have male and I have pierced ears. I already defined those over here as A and B. So we could say probability of A and B equals what? Because instead of A and B, instead of saying male and pierced ears, I'm shortening it up, probability of A and B. So we look at our chart and we're like, who are my people that are male and those males have pierced ears? How many is that? 19. Here's my males, they have pierced ears. There's 19 out of 178 people. You've got 178 students total, people total. In that whole group of people, we do have 90 males and we do have 103 people with pierced ears, but specifically there are 19 males that have their ears pierced. We have 19 out of 178. Is a male or has pierced ears. So I'm going to shorten this up. Is a male, we said, and I'm actually flipping the letters around just to keep it alphabetically. Is a male or has pierced ears. So over here, how many males do I have? I have 90. And then if I look at pierced ears, I have 103. Is that going to be okay? No, why not? Because it's more than the total. 103 plus 90 is 193, and we only have 178 students total, so we're like, something's not quite right, right? You can do this one of two ways. You can say we have 90 males plus 103 people who have their ears pierced out of the 178, but we need to subtract what? We need to subtract this 19 out, because this 19 is included in this total, and it's also included in that total. 19 is being counted twice, so we subtract it out. And here's where we were talking yesterday briefly about this term mutually exclusive. These are not mutually exclusive because somebody can be male and they can have pierced ears. This is not mutually exclusive. So 90 plus 103 minus 19, what does that give us? Some people are like, well, Ms. Rupp, couldn't we just done this? You could also say probability of A or B equals this. We've got a 19, we've got a 71, and we've got an 84. Can't we just go 19 plus 71 plus 84 and divide by 103? That gives you the same thing when you add those three numbers together. Whichever way makes more sense. 178 there. Yeah, good catch. Okay, that's just the gist of a two-way table and how we can find probabilities there. And Tyler's like, couldn't we just take this 4 and subtract it from the total? Yeah, because these people do not have pierced ears, and they're female, and that's not what I'm asking. That's like the complement of it. So you could go 1 minus that 4 and get your answer that way too. So we can take that information, and then we can also put it in a Venn diagram. And here's what we're having this represent. We've got one circle here. You've got another circle over here. What do we know? In the center is the part where it overlaps, right? You have males, you have people with pierced ears. The part that they overlap, this is where we get our 19 out of 178, which is what we see here. We've got 19 males with pierced ears, and that's the part that overlaps. So we can take this information, we can show it in a Venn diagram, and we have this rule that we just actually looked at, and we're going to formalize it here. The general addition rule for two events, if A and B are two events resulting from some chance process, we have probability of A or B equals probability of A plus probability of B minus that overlap, minus the probability of A and B. Here's what we did up here. We said the probability that they're male, the probability that they have pierced ears, but then we had that number that was being counted twice for both categories, so we have to subtract that overlap out. We'll look at an example in a little bit. Complement of A to the C, that says what is not in A. When we talk about the complement of A, it is the outcomes that are not in A. The complement of A, we're talking about all the stuff that would be outside of A, what is not in A. Mutually exclusive, if they do not overlap, that means they cannot occur together, or they have no outcomes in common. If they're mutually exclusive, they have no outcomes in common. These symbols I had never seen until I got to college, and then it was all this new stuff, and I was freaking out because I didn't have a clue what it meant. Okay? Maybe some of you have already seen it, I don't know. This says the intersection of events A and B. Often, what you're going to see is this symbol right here. That symbol means intersection, or and. It means both of them. So this symbol just means intersection. And this one, like a U, is called the union. So this is the one where a set of all outcomes are in both A and B. The set of all outcomes in A and B. The intersection, kind of like it says, where do they intersect? What's in common between both of them? If I have this circle here and I have this circle here, what part overlaps? That's the intersection. The union means one or the other. It's the set of all outcomes in A or B. This one's and, this one is or. It can be in A, it can be in B, either one. We take those two, we join them together, that's called the union. So what we can do is we can use the Venn diagram to display information and determine probabilities. So I'm going to flip gears on you. We're going to say A represents male and B represents pierced ears. And I know you have this already in your notes, but I want to walk through with you how do we draw this and what does this look like. So we always start, we have a big rectangle for our Venn diagram, and then we put our circles inside. So we're going to say A is male, B is pierced ears. So I'm going to say, hey, this circle, A, represents male. For this circle here, let's say that's B, and these are the people that have pierced ears. And I don't know what you guys are going to like best, but I like to start in the middle and kind of work out from there. Because the middle is the overlap. The overlap of the male, the overlap of the pierced ears are males with pierced ears is what's in the middle here. So I look at my chart and I have my pierced ears, I have my male, the overlap of those two, I have 19 that's in common between both, and I put that in the center. Because that just kind of helps me keep things straight. Because if I look at the male circle, 19 of them are in both, but total, how many males do I have? We have 90 males total. So in this circle, when I add these two numbers together, whatever number plus 19, total it has to add up to 90. So what do we have? We also have the 71 that's missing. We have males are 71, and they're not in that other circle because they do not have pierced ears. And then I look here. I'm like, well, what about this circle with the pierced ears circle? 19 of them are male with pierced ears, but who else has pierced ears? Total, I have 103 people with pierced ears. So this circle has to add up to 103. 19's already accounted for. I have 84 people with pierced ears that are not male. They're not in the male circle. Did you see that? Okay. And then how about this 4? This 4 is unaccounted for. 4 means they don't have pierced ears and they're not male. They're female. So where's that 4 go? Outside, right? They're not male. They don't have pierced ears. So I put a 4 outside. So I have all 4 of those numbers accounted for. If I added all 4 of these numbers together, you would get 178, just to double check yourself. That's the Venn diagram. And so, lastly, we have these regions of the Venn diagram. We want to write in words. What is it telling us? Symbols come up all the time, and you have to know what those symbols mean. And then we'll also put the count for that. So if we're in the intersection of the two circles, what does this mean if we're in the center part right here? Tell me in words, who are those people? They are male, and they have pierced ears. So we're going to write it. We have male and pierced ears. So the symbol for that, it's the part they have in common. It's the intersection. So that's where we use the symbol for intersection. We have male is represented by the A, and the intersection of B, which is the pierced ears, and how many are in there? We have 19. The next one, inside circle A, outside circle B. I am inside circle A, but I'm not a part of circle B. Who are these people? They're male without pierced ears. They're male and they do not have pierced ears. And real quick, we look at that and we're like, oh, there's 71 people there. Now let's figure out the symbol. They're male and they do not have pierced ears. So am I inside circle A? Yes. And am I in circle B? If we have no pierced ears, it's like the complement of B. So we say B to the C. It's like the complement. You're not in B. Inside circle B, outside circle A. Here's circle B. We're not a part of that circle A, though. So here I have 84. Who are my people? You could say females with pierced ear. You can say the female, or you can say not male and pierced ears. So if you're not in the male category, if you're not in that A, that means we have the complement of A. You're not male, that means you're female, so it's the complement of A. And are we in B? Do we have pierced ears? Yes, so you are in your B. And if you're outside both circles, That means we're out here somewhere. That means we have 4 that are outside. So if you're outside, that means you are female and you don't have pierced ears. I'm not an A and I'm not an B, so that's the complement of both of them. So A, the complement of A, and the complement of B. And we're going to work with the union a little bit later. I have this matching thing for you guys to wrestle with. This is just the exact same thing we just did, just following up with a different example one more time. If you got it, have at it. Otherwise, we can walk through this together. What's the relationship between educational achievement and home ownership? A random sample of 500 people who participated in the 2000 census was chosen. Each member of the sample was identified as a high school graduate or not, and as a homeowner or not. The two-way table displays the data. Suppose we choose a member at random, find the probability that the member is a high school graduate. So I could come in here again and I can say probability of a high school grad. But I don't like to write all that when I could just use one letter. So what I do is when I come to this, I'm like, well, let me come up here and let's say, well, A represents high school grad, and then B, what else are they talking about in here? Owning a home. And just define it, own a home or homeowner, or however you want to say it. So probability somebody's a high school grad. Here's my high school grads. I have 310 out of 500 people. You can cross off your zeros if you want, you can simplify it if you want, but I'd say let it. Is a high school grad and owns a home. So I'm gonna use my symbols here. Is a high school grad and owns a home. High school grad and owns a home. So you can say A and B. Some of you even want to shorten that up. If it's A and B, both of them together, that's the intersection. So some of you could write like this. Probability of A and B. That's just the intersection of those. So look at your table, think about it a second. Who's a high school grad and owns a home? 221 out of 500. And part C, is a high school grad or owns a home. So here's where I have is a high school grad or is a homeowner. If it's or, it's either in this one or it's in that one. And that's where when it's in one or the other, that's called the union. And so our symbol kind of basically flips upside down. Probability of A or B. High school grad or owns a home. These are my high school grads. These are my homeowners. If you want, just go 221 plus 119 plus your 89 and put that out of your total. All out of 500. You add those all together. 429. Yep. Or like Tyler said earlier, can't we just do the complement? Couldn't we just say 500 minus the ones that they're not? Yeah. You could go 340 plus 310 and subtract that one that's repeated too. Fill in, just like we did with your words, symbols, and your count. I drew the Venn diagram kind of sort of for you so we can fill in. What did we say A represents? High school grad. B is your homeowner. And again, I'm like, what's the overlap? What's in common between both of them? High school grad and homeowner. I have 221 in the center there. So then of my people who are high school grads, I have this whole circle here. So high school grads, I have 310 total. 221's in the intersection. That means 89 is in the other part of the circle. So I have 89, 221, you add them together and you get your total for how many high school grads you have. And then in the other circle, we have our homeowners. I already have 221 are high school grads and homeowners. In that circle total, I have 340, so my 119 for my homeowners goes here. So when I add those two together, you get your 340 homeowners that were represented in the table. And not high school grads and not homeowners, neither one. We have not a homeowner, not a high school grad, you have 71. Goes outside.